So is the sun setting in the water? Does the sun and moon rise and set out of the water? We're going to be exploring that today, and also the celestial sphere itself. Now, I'm Stephen Alonzo from Flat Earth University, so I want to be going over a very important concept in astronomy. So you see right down here, we have an observer. And just so you're wondering, I've been using a controller. I'm a senior flat earth researcher. So I reached the point where the keyboard, to try to do it with the keyboard and mouse, works, but it's been holding me back in my research. So the controller has now advanced to a very high level of input. So let's go to this view here. I want to talk about where we are then right now on our Earth. You can see in the left-hand side, let me zoom that up. We got a latitude of 0 degrees and a longitude of, it actually doesn't matter the longitude. And I can change that just so you see. As we change longitude, it doesn't matter, because what we're talking about for right now is the north and south celestial poles. So see the red and the blue? The red is the north celestial pole, and that's pointed to the North Pole, and then the blue is the south celestial pole, and it's pointed away. Now, I want to go to a bird's eye view if I can, and then open up the slide where we talk about magnetism. Because this is what seems to confuse a lot of beginners when they come to the flat earth sciences. They are used to a dipole magnetic field, and their reasoning is right, but their assumption is false. So for people who are new to just magnetism in general, you'll want to look into a radial field, which is what the top right photo is showing, and also a toroidal field, which is very commonly as well described, although mathematically it's harder to represent and harder to argue on our flat Earth. So for me personally, I choose that top right image, the radial field, and I can argue why that works, and the magnetic field is well researched in there. So I just want to explain that. So the north celestial pole is pointing to the North Pole, and here's where the I guess implementation is. So let's move closer to the North Pole, and you see now how within our perspective the North Celestial Pole rises. If we put our latitude right to 90 degrees, the North Celestial Pole is straight up, and that is where Polaris is. So a lot of you are familiar with the declination of Polaris, and a lot of you who live in the South Pole are also familiar with the Southern Cross and your South Celestial Pole. So let's actually change the latitude down to where people in like Australia and New Zealand would be, and you see how now this blue dot, that is your North Celestial, or your South Celestial Pole, sorry. So we can face that, and we can also look at astronomy software and see that what I'm saying is actually true. And I'm going to show this to you in a second when we load up Stellarium. I'm going to show you how I did these photos on the left, just so that you can replicate it yourself, because that's a really important thing. Science is about being able to replicate your methods, and that's one of the reasons we know that flat Earth is true and that the globe model is false, because it's hypotheses that we have falsified and that often cannot even be falsified, whereas everything about flat Earth, you can take the photos yourself, you can look at the focal length of the lens, you can prove that they're using a fisheye lens to deceive you. And even with astronomy, flat earthers often tend to like P1000 cameras, but they're still using an EQ mount. So the people who have telescopes and the people who have P1000s, the way they track celestial objects are all the same. So I'll actually just open up Stellarium right now, just so you know that I'm not bullshitting you. So you can, is it this way? It's this way. So the link is right there, and you can load that up for free on your computer and see the exact same thing I am. I am located in Belize. So that means my latitude is 17 degrees north. So let's see what the flat Earth model predicts. Let's go and adjust the latitude from negative 33 to about 17 degrees. And I can tell already this looks like it's gonna match what the globe model is also confirming. So see that? This is called the equatorial grid. So when you load up Stellarium, you're going to have a menu on the bottom. And this is one of the reasons why you have to load it on your computer, on a nice big monitor if you can. Because your phone, it'll load into a mobile version more for fun, not really for serious research. You need to be able to turn on the equatorial grid. So if you only see this, you're not being able to do anything. This is just like the app version. You need to turn on the equatorial grid and not the azimuthal grid. There's a huge difference. The azimuthal grid is just a way to measure how high or low something is. For example, the moon up here in the top left, it has a horizontal tilt of about 40 degrees. Each of those bars there is 20 and 20, so 40 degrees is how high the moon is. But that's not what we're talking about right here. We're talking about the equatorial grid, which is also called the celestial sphere. So make sure that you're familiar with this universal concept, is what I would say. The celestial sphere, as I explained earlier, is used by both flat earthers and globers. It's a universal way from the observer's perspective to be able to locate celestial objects in the sky. Now that's very important because they don't claim that this allows us to locate the physical position. The globe theory admits that you cannot locate the physical position, like in three-dimensional space, using the celestial sphere. Now that is one of the reasons why these types of software only show you the first-person view. For example, in Stellarium, there's no way to zoom out and see the three-dimensional view, because that debunks the globe. If you have a flat Earth model where you have an advanced tool like this where you can zoom out. Oh, I have to turn off. Hold on. Oh, the battery shut off for safety. But yeah, so you have an advanced tool like this, and you can zoom out. You see then that the Earth is flat. And the celestial sphere even actually admits that. You'll see in some of these photos, I might be able to zoom up while I take a drink of water. My mouth is dry. So look at these photos and see how they have that flat surface. This is how I was saying earlier, you can tell the angles up and down. If you're measuring from a curve, you just can't do those types of angles. Oh, that's good water. Make sure to drink like 4 liters of water a day. Seriously, I drink about 5 because it's a hot country. But the celestial sphere is what I'm claiming here. It's nothing suspicious at all. So for example, Polaris. As we know, Polaris is at the top of the firmament. And that is what I was showing you over here. As you move towards the North Pole, that red dot, and I can go into my first-person perspective and look up. That dot there is Polaris. And as you move your latitude, let me go to 17 and try to find the surface again. My north celestial pole, which is Polaris. So at nighttime, Polaris will be right there, and I can search it up right here. So you can verify all these claims yourself. So where is Polaris? You see how it focused right on that little dot there? And that's how you can confirm that what we're trying to say is true. So 1 degree for every 69 miles is how light seems to bend. This can be confirmed in a few ways, but I want to mention something very interesting. I wrote an article about how this works, and it's based off of a guy named Shane St. Pierre. These photos are from his. I didn't make these photos. But what he's trying to argue, or at least how I interpreted his research, is that we have a vertical field of vision that is about the same degree as how the globe model is, the 1 degree for every 69 miles you go. So one very strong argument is that for the curve of your vision, what they're seeing is actually a flat Earth. They took the curve of your vision and manipulated that. So that's a very interesting argument to look into. Now, another thing to understand is that these are observer-centric models. So these are the apparent positions. It's not actually where it is. These are the apparent positions from a flat surface. And that's how flat Earth models are really the same thing as globe models, and globe models are really the same thing as flat Earth models. They are observer-centric observations. And the way these models work, they're not actually based on any geometric shape. It's a series of polynomial equations, trigonometric equations, but mathematical sequences based on patterns and observations that have nothing to do with any shape of the Earth. So you can read all these articles, the Journal of Geocentric Cosmology. I have a whole bunch of stuff where I go into a lot of the stuff we're arguing and why it works the way it does, why celestial navigation, for example, you can test this yourself, that Polaris will be about 69 miles for every degree and about 111 kilometers. And you can use this to actually figure out where you are in the world and how far you have to travel. So you can practice these celestial navigation yourself using the celestial sphere. That's how it works. So it's important to understand that even in globe science, it works the exact same way. There's only one model, and it's important to understand that people who believe in the globe are not necessarily stupid. They have a valid interpretation for why it works, much in the same way we have a valid interpretation for why it works as well. There's two ways to interpret it, but the reason why our interpretation is valid, let me get back into photo mode. That's another reason why I use the controller, so I can clear the screen and get it for presentation mode. Flat Earth is the only model that admits or allows you to zoom out and see the three-dimensional area. The globe has no model. They have astronomical models, but those are the same as flat Earth models. And you can look into these yourself. I give you the names here. So there's VSOP 87, there's the D series model, there's the ELP 2000 model, and the IPOP model. You can look these up online, see the source code for these mathematical constructions that have nothing to do with shapes or any three-dimensional models. You can't model the globe, and the more you look into this, it becomes easy. Like I can confidently say this because I've looked into how this works, and you can test this yourself, and I really want you guys to. So that's very important. Flat Earth is the only system that allows you to zoom out, see how everything works, and go right from to the observer as well. So let's go up to the sun. I was actually talking about something very important at the start of this video. So is the sun actually setting in the water, or is that just how our perspective is? Now, it looks like it actually does set in the water, and I want to suggest also that the Book of Enoch strongly argues this as well. They have these gates or portals where the sun would literally go into. Now, the reason why I believe it works better in a celestial sphere model is that these gates or portals can move. So see, as I adjust my longitude, we're now out in the water. And let's continue going, and now we're over on land again. And that is what we observe in real life. You'll see people in a plane who have videos of the sun below the horizon. So let me go out and show you what I mean. Someone in a plane will have a photo of, in the water, see the sun right there? They'll have a photo of the sun kind of disappearing into the water, just like that. And that is what's actually happening. That's how the celestial sphere projects it for us. And it's really important to understand this because most people, like everyone actually, when they're first introduced to flat Earth, how does the sunrise and sunset work? If it's just a physical object spinning around us and that is exactly how we see light and how light behaves, that wouldn't really make sense. Now that I'm mentioning one thing of how light behaves, I want to see if I can find the paper where I mention how light bends and why it works the way it does. I think right here. So there is something called gravitational lensing. There's something called the black sun. There's also something called light diffraction and wave diffraction. So it's very important to understand that the actual object can be different than the apparent object. It's very important to know that because early in 2007, a genius flat Earth researcher named Walter Bislin modeled this, but he was unable to figure out how light bent this way, often because a lot of people just denied gravity. So I'm going to mention one other thing as well. If you're denying gravity, I have a whole video here on flat Earth calculus, and I show us how over an infinite plane we do get perpendicular vectors, and that's super important to understand. I have a video too where I walk you through this all, but mass does attract mass on flat Earth, and we can determine how thick Earth is, and that's about 18,000 kilometers. So that's fascinating to know. And gravitational lensing is well researched in globe theory as well. So that's something I want to mention. Globe theory takes a lot of stuff that is true and manipulates it to support their ideas. So just because the force of gravity is true doesn't mean that gravity can hold water to a ball. The theoretical applications of something are completely different than the first principle concepts. That's super important to understand. As you can see here, we're not even talking about Newton in here. This is Gauss's law of gravity, which is a well-known concept in third and fourth year undergraduate physics. When you're in university, you will be taught this. And I've actually been banned from globe science boards for posting this because they confirm the math is right and this solves a major problem in flat Earth. A lot of people will try to strawman that we have a floating disk in space model. And if you have a finite floating disk, then they're right. Gravity would pull to the center of mass and you have to walk uphill. So it's important to understand this, an infinite plane, and you have to use calculus. You have to apply Gauss's law to integrate over this infinite plane. And the symmetrical spread of mass does give you the perpendicular straight down gravitational vector of 9.8 meters per second. Flat Earth works. Science proves flat Earth. So going back now here, yes, the sun is actually setting into the water, and that's from your perspective. That's your apparent perspective, and there's nothing wrong with that at all. It makes perfect sense, especially with Polaris, which is a lot easier to understand because it has that 1 degree for every 69 miles that you move away from it. And then let's go to the equator. Let me get out the senior research tool and then move our latitude towards the 0 degrees. So see now how we're here? That is when the south celestial pole starts to become visible. So as you see, as you move past the equator, it's now in the ground technically. It's past your perspective. And you can't see it anymore, where you can start to see the south celestial pole. So you'll be able to see the Southern Cross and Alpha Centauri and the stars we're talking about here. So I think I have a slide where I talk about that. So you see there, It's important to understand what's actually happening, where the equator is when you move past the equator, and where the south and north celestial poles are. And hold on, I'm just going to take another drink of water. Study this for a second. So yeah, that photo is in Chile and New Zealand. And what this is actually showing is that from different parts of the South Pole, South Celestial Pole, the same constellation is visible, but slightly rotated. So in this case, that circled area is the Southern Cross. So that's important to understand, and that also depends on your latitude as well. So depending on where you are, the celestial sphere itself will be rotated to a different part. So I hope this makes the concept pretty clear about what's happening. So let's actually do something really cool. Let's go to Union Glacier Camp. So negative 79 degrees south latitude. And let's set the model for December, I think it's December 20th when they're going. And let's see what the Flat Earth model predicts. Let's test our claims. This is what we do as senior level Flat Earth researchers. So the sun is visible, but will it be there now for 24 hours? Let me zoom up on the left so you see what we're working with. If I adjust the time, yeah. So the Flat Earth model predicts that there will be a 24-hour sun when you're past the ice wall in Union Glacier Camp. And let's see how close you'd have to get. So let's adjust our latitude until the sun's no longer visible. Right about there. So actually, yeah, 60 degrees. Okay, yeah, so it's quite interesting. So you know the Antarctic Treaty is at the 60 degrees south latitude. Coincidentally, they don't want you going far enough to really test this unless you're on one of these guided tours. So that is interesting. You have to be past negative 60 degree latitude to see the 24. Well, it'll be a little below it, so 57. So to be fair, you'd have to be at 57 degrees south latitude, and that's anything past that is when you can see it. But when you're way out at Union Glacier Camp, it'll be quite high as well. So you can go to your first person perspective. Let me go back into photo mode so we can see the nice view. So yeah, that's what it will look like for them. They're gonna see the sun travel around that line. So see this line right there. The sun's gonna travel along that, and they'll see it for 24 hours. And in my opinion, all that's gonna do is help prove that this flat Earth model is correct. It's called the celestial sphere model, and the original credits for the scientific research go to Walter Bislin. He did this model in 2017, and you can find the original link for it. It's not this actual model, it's a different concept. Walter's didn't allow first person, and it was coded, I think, in plain JavaScript. Walter used plain JavaScript when he did his way back in the day. And I'll put his link in the comments as well, because it's really important to see how science advances and how over time research confirms previous research, and we just get better at knowing how flat Earth works. So I think this is also cool. You can go to this yourself. The link's up here as well, model.flatearthuniversity, celestial sphere. I'll put it in the comments. You can test your hypotheses yourself. As you see right now, we're confirming that there will be a 24-hour sun in Antarctica. Now, the only other model that is astronomically arguable is the solar noon kind of AE model, where it's talking about like the sun and it'll be kind of weird, but it's not really an astronomical model. Like the flat Earth apps, they're correct, but only for solar noon. you can't make the type of first person predictions like we're doing here. You can't see, for example, we were able to test what will happen at Antarctica from an observer. You can't do that on most of the apps. Now we're working on a new app, not me, the Firmament Trackers. There's a Facebook group for us, and we're making a high-end app that will incorporate a lot of this stuff, and you can debunk the globe. Stuff like this is just fascinating. So I talked now for about 25 minutes. I think I explained enough, at least how you can even use this model yourself to set a date-time prediction and see the behavior of stuff. I think it's super important to test this and see how astronomy works. What is declination? What is right ascension? I can give you guys a very quick example of what that is. Let's go to the North Pole. So let's play with the moon, actually. The moon will be really good to play with. The declination of the moon at 90 degrees is at the North Pole. And that's the same for any celestial body. So the declination of Polaris is also going to be at 90 degrees. See right up here in the top left? It's going to say 89, and they're true. It's slightly off. It's like 1/5 of a degree off, but it's roughly at that 90-degree declination. So that's very important to understand. Declination is talking about the celestial sphere, how objects on the firmament relate to real life. And as declination goes down, it slowly goes down and down. And then you get to the negative parts where it's only visible now on the south celestial pole. So for example, the sun right now has a declination of -20, and we can't see it because our perspective has taken us to the North Pole. But if we move away at 1 degree for every 69 miles, we eventually will be able to see where -23 is. So actually, we can put it probably about here, and through 24 hours, the sun will become up. Yeah, see right there? So that's where... Oh, let me adjust the view, sorry. So that is where the declination of -20 is. That circle there around the bottom of the firmament. So I hope I gave you a very good understanding of this. Please load the model yourself. It's free. Please also go to Stellarium and load the model yourself. Where was the link? Oh yeah, the link was right here. So go to Stellarium, load it yourself. It's very easy to use, very easy to understand, and you can see that what I'm saying is true. The moon here has a declination of 27 degrees, so it's on that topper part of the firmament. Now, I want to also let you guys know that there is the Flat Earth Science textbook coming out September 1st. It's a hardcover textbook, 150 pages, 10.5 size font, 2 columns, and it's $50, but it's a hardcover textbook. And then I also have an ebook. It's over here is the ebook. It's $5. It's 370 pages, and I originally wrote it in 2022. But in regards to the Flat Earth Science textbook, it is serious science. So we teach you how to argue and how to actually understand the stuff I was saying earlier. How does a toroidal magnetic field work? How does a radial magnetic field work? And we go over everything too, even stuff such as biblical cosmology. What is the firmament? What is the rakia? And argue why our interpretation is valid, but also explain other interpretations as well. For example, you can read the original Hebrew and come to your own conclusion. That's the whole point, teaching you how to become smarter, how to become stronger, and it's real science too, so it's full of academic references. This is just part of the first page. But everything we say is backed up by real science, and that's why globetards will run. If you bring this to a debate, no one will even want to challenge you. They'll block you, and it's real science. So I encourage you guys to also take a look through that other book I mentioned. It's that $5 ebook. I uploaded 75 pages for free, so you can see what I'm trying to talk about, and it's a very personal book as well, and it's the original one from 2022 that I never published. So this was when I was going through a lot of esoteric work with the Order of the Golden Dawn, and I really understood a lot of stuff that I shouldn't talk about, but I chose to, and then now I decided I do want to release it. Everything is there, and it's a fascinating book for $5. The hardcover is not available yet, so it's just an ebook. Finally, we got the Flat Earth AE map. It is a 60 by 90 centimeter acrylic, no, not acrylic, canvas, it's called, canvas print of the Gleason map. Now, this is 20 US, shipped anywhere in the US. Now, go on Amazon, look for this exact thing, 60 centimeters across by 90 tall. It'll be $35. I'm serious. So because we're just a good company trying to help you out for academic purposes, we can sell it to you for $20 US. And then we also got shirts as well. So this is $20 US for a nice flat Earth. It has the UN logo on it. And again, $20 US for a top quality shirt. Again, I'm Dr. Stephen Alonzo from Flat Earth University. Thank you for watching the video. Don't forget to enroll in the Master of Flat Earth Theory course. You can do that at flatearth.university.com and enroll. The course itself is free. If you're able to complete the course, you are entitled to call yourself a certified master of Flat Earth Theory. But if you're a glober watching this, you have no chance of ever achieving this. If you're a flat earther, you can go through a lot of the stuff and try to understand a lot of these concepts. And I know it sounds funny, but I strongly believe that flat Earth is proven because science and math confirms that. So that's why there's tons of publications. Again, the Journal of Geocentric Cosmology. Go there, take a look through this all, understand why stuff works. In my opinion, anyone who tells you gravity doesn't exist, you don't want to listen to them. And then also go to shop.journalofgeocentric cosmology for the $5 ebook, and then the $50 pre-order of the hardcover textbook of Flat Earth Science.
Flat Earth Steve, I be debunking some globes, y'all. I be debunking some globes, y'all. Flat Earth Steve, I be debunking some globes, y'all. I be debunking some globes, y'all.